Aryabhata's birth story. The Gupta Brilliant Age, 4th-6th centuries AD, was not only a golden age for art, architecture and literature, but it was also a golden age for science, mathematics and astronomy. Many important discoveries were made during this period. Aryabhata's name is one of the famous mathematicians and astronomers of that time. Aryabhata founded the decimal system, trigonometry, calculated the value of pi, and discovered our solar system, while mathematics and astronomy were still in their infancy around the world. His works were widely used by the Greeks and others in the Middle East. His most famous work Aryabhatiyam was composed when he was only 23 years old. Aryabhata, also called Aryabhata I or Aryabhata the Elder, born 476, possibly Ashmaka or Kusumpur, India, astronomer and the earliest Indian mathematician whose work and history is available to modern scholars. He is also known as Aryabhata I or Aryabhata the Elder to distinguish him from the 10th century Indian mathematician of the same name. He flourished in Kusumpur, near Patalipurata, Patna, then the capital of the Gupta dynasty, where he composed at least two works, the Aryabhatiyam, circa 499, and the now lost Aryabhasiddhanta. The doctrine of Aryabhata. The Aryabhasiddhanta spread mainly to the northwest of India and had a profound influence on the development of Islamic astronomy through the Sasanian dynasty of Iran, 224 to 651. Its material is preserved to a lesser extent in the works of Varamihira, n. circa 550, Bhaskara, pronounced circa 629, Brahmagupta, 598 c. 665, and others. It is one of the earliest astronomical works from the beginning of each day to midnight. Aryabhatiya was particularly popular in South India, where many mathematicians wrote commentaries in the coming millennium. The work was written in verse couplets and deals with mathematics and astronomy. After an introduction consisting of an astronomical table and Aryabhata's phonetic number notation system in which numbers are represented by a consonant-vowel monosyllable, the work is divided into three sections: Matha, mathematics; Kalakriya, mathematics; count of time; and the sphere. Aryabhata's theory of mathematics. Aryabhata wrote various numismatic and cosmological texts, the first of which was Aryabhatiya. He was only 23 when he wrote this book. Aryabhatiya covers many areas of mathematics, including algebra, arithmetic, plane and spherical trigonometry. Aryabhatta in Mathematica names the first 10 decimal places and gives the algorithm for obtaining square and cube root using the decimal number system. He then treats the geometrical measurements, employing for 62,832 20,000ths, equals 3.1416, which is very close to the actual value 3.14159, and develops the properties of equal right-angle triangles and two intersecting circles. Using the Pythagorean theorem, he derived one of two methods for constructing his sine table. He also realized that the sign difference of the second order is directly proportional to the sine. His primary interest was mathematics. He acquired amazing knowledge of arithmetic and geometrical motions like 2, 4, 6, and 8 or 2, 10, 50, and 250. Tactics used by the Greeks. He also formulated an approximation of pi and found that pi, p, is irrational. Arithmetic and algebraic topics include mathematical series, quadratic equations, compound interest, involving a quadratic equation, ratios, proportions, and solutions of various linear equations. Aryabhata's general solution to linear indefinite equations, which Bhaskara I called Kuttikura, pulverizer, involved breaking the problem down into new problems with successively smaller coefficients, essentially the Euclidean algorithm and the method of continued fractions. Related to topics included definitions of different units of time, eccentric and epicyclic models of planetary motion, see Hipparchus for an earlier Greek model. planetary longitude corrections for various terrestrial locations, and lords of hours and days, an astrological concept. Aryabhata worked on the place value system and found 0 for the first time, using letters to represent numbers and highlight attributes. He accurately stated that there are 365 days in a year, plus a 7-day week and an intercalary month in a year to make the calendar seasonal. He identified the positions of the 9 planets and said that they too revolve around the Sun. He described the circumference and measurement of the Earth as well as the radius of the orbits of the 9 planets. Aryabhatiyam ends with spherical astronomy in the sphere, where he applied plane trigonometry to spherical geometry by projecting points and lines on the surface of a sphere on suitable planes. Topics include the prediction of solar and lunar eclipses and an explicit statement that the apparent westward motion of stars is spherical on Earth's own axis.